Shall we start?
Yes, sir.
Yeah. So, now we are considering the fully non-linear first order equation in two variables x and y. So first thing is we call this as z variable, u as z variable, and this as p, and this as q. So first of all, there is something called non-degeneracy assumption. That is, we want to make sure that this equation is really of first order. Okay, to under what assumption this equation is first order? We should not. We should have the derivatives ux and uy terms in this. So, what is the non-degeneracy assumption? That fp square plus fq square is not equal to 0. Okay, what happens when fp square plus fq square is equal to 0? What happens is this implies fp square is equal to fq square. Okay, this happens both fp and fq are equal to 0. That means what? The function is independent. When you do a differentiation with respect to p and this differentiation with respect to q, both are zeros. That shows that this function has no p and q terms. Okay, there are no, really the ux and uy terms are not present in this equation, this function. So this should not happen. That means what? There is no ux and ui. This is only a function of u. You can write directly u is equal to. There is nothing to solve here. This is not a. This reduces to. This implies f is a zero order, not first order, zero order, zero order function, zero order equation, differential equation. There is nothing to solve. We want a first order differential equation. So we don't want fp and fq simultaneously 0. That means this is the assumption that we should have. Okay. So the first thing is this one. Next is we should know something about implicit function theorem. Okay, under what condition we can write here, if you see the f, for example, in the previous quasi-linear case, if you see the equation, this is quasi-linear equation, quasi-linear PDE. Okay, what A, B, C are functions of A is a function of x, y, u, and similarly B is a function of x, y, u. C is a function of x, y, u in a quasi-linear PDE. So this is our ux, this is our uy. So we are writing the AUX plus BUY is equal to C in this format. Okay. So what happens is if you see here, we can write clearly, this is an implicit equation. We can write Q, function Q, in terms of P. Okay. We can write here, because this is we can A, B, C are the given quantities and only P and Q are there, so you can write Q is Q in terms of P. But in the general case, in the fully nonlinear case also, if you look at it as at a point x naught, y naught, z naught, you can if you have this, okay, in the R3 at a fixed point x naught, y naught, z naught, we can see this also. This function is also a function of implicit function of P and Q. Okay. So from here, by if with the assumption that FQ at this point, FQ is not equal to 0, by implicit function theorem, we can write Q as a function of P. Okay. Q as a function of P. So that is the second point here. We have to first is the non-degeneracy condition assumption. Second is recall what is implicit function theorem and what is the hypothesis. It is we want to write use to write P. Is the connection okay? Am I audible?
Yes, sir.
Oh. So why we are writing is just to uh, we want to write. Third thing is we want to write the equation of a tangent plane the surface to the surface z is equal to uxy at a point x naught, y naught, z naught, having p and minus 1 as an orthogonal or as a perpendicular, as a perpendicular. That is, suppose we have this x, y, z, and let us say this is our surface z is equal to uxy, and take a point x naught, y naught, z naught. We want to know what is the tangent plane having at this point, okay, tangent point, and having a orthogonal p q of p and minus 1. Okay, so we want to know the equation of the tangent planes, because these will generate for us. So because of this, what is the equation of a tangent plane passing through a point and having some orthogonal, having the perpendicular, we can construct that. What is the equation known to us? It is p q minus 1 dot passing through the point. So x minus x naught, y minus y naught, z minus z naught is equal to 0. This is, or you can write z minus z naught on one side is equal to p times x minus x naught plus q times y minus y naught. This is the equation. And if because of this q depending on p, this is only one parameter. That the parameter is now, because of this dependency, this is one parameter family of tangent planes. Why a family? It is tangent planes because we can vary the perpendiculars. Vary at every point. We can go now to a different point and a different perpendicular and get a different tangent plane at that point to the given surface z is equal to uxy. So we'll understand why we are requiring this one parameter family of tangent planes. So in general, what is the I'm giving some examples. Suppose take one parameter family of circles. Suppose we have x, y, and z. Take a point on the x-axis, that is a comma 0 comma 0, and take a disk with radius 1. Okay, now change the radius a, but the same radius, change the center now, and but same radius 1. Okay, so this is a family of disks, unit disks, with center a comma 0 comma 0. Okay, let us denote by this family as a, because only parameter that is depending is a. As you change a, you get the family of a belongs to the positive side of the x-axis for a positive. Okay, so what we so now this is a one parameter family. So what is the um, what is called an envelope? Envelope is, suppose you have this family of circles, discs, and what is the what is the surface that is generated by these family of discs? That means what I'm saying is, because this is a function, this z I'm denoting it by w x y a. These are the surfaces SES. These are surfaces, and I take this is equal to Yeah, this is one thing, and because this is a function of a only, I can differentiate this with respect to a and equate it to 0. Okay, so the yeah, so what is the, yeah, z is equal to SASR. So consider this equation, the one parameter family of surface. What is the equation here? SA, x minus a whole square plus y square plus z square is equal to 1. These are the, in fact, not disks, they are the spheres. Okay. Sphere equation is x minus a whole square plus y square plus z square is equal to 1. Or you can write this as -1 is equal to 0. This is our WA. Okay. So this equation we have, and we have differentiation of this with respect to a is equal to 0. What do you get if you differentiate this with respect to a? So another, what is that surface? And yeah, so if you differentiate this for a function of x and y, yeah. So now you get this implies w a is equal a function of xy. Okay. After solving this equation, you get a is equal to xy. We'll demonstrate that. And now substitute here the envelope. How to? So in this example, the envelope will turn out to be, in this example, what is the dw upon dA? That is equal to twice x minus a into minus 1, because we are differentiating with respect to is equal to 0. This implies x is equal to, this implies x is equal to a. Okay. Now, yeah, when you substitute this x is equal to a in the first equation, what you get is y square plus z square is equal to 1. This is what, this is a cylinder, equation of a cylinder in the yz plane, the yz plane. That is, uh, this is the cylinder. This is y square plus z square is equal to 1. This is x, this is y, and this is z. The cylinder like this. Usually we know what is a cylinder in the xy coordinates. Like we have, this is x square plus y square is equal to 1. Okay, when it is z like this. So this is the envelope for this family of surfaces, SCA. Okay, for if you take the spheres, SCAs as family of spheres with unit spheres with with the center as A00, envelope of this will be cylinder. Okay, surface of a cylinder. And now come back with this example. Come back to the family of planes, tangent planes. Then what will be the envelope here? Come back to our tangent planes. So what are the tangent planes in our case? Yeah, dz is equal to p dx plus q of p dy. Okay, and now you only parameter is this is one parameter family, and that parameter is p. So now if we differentiate this, what we get is a differentiation of this with respect to p. This is 1 and dx plus del q upon del p dy is equal to 0. So we have this equation, and we have also x, y, z, p, q. This is equal to 0. Differentiate with respect to p this equation. What we get? We get we get fp plus fq dp upon dq upon dq upon dp is equal to 0. Now compare this equation 1 and this equation. So if you see this, what we get is dx upon. So these two are collinear. That is common ratio dx upon dfp and is equal to dy upon fq. These are two things, because this is see, this is same thing here, because this is also dq upon dp, and here also this is. So we get two equations now in parametric form. You can write it as dx by dt is equal to fp, and dy by dt is equal to fq. And what is dz by dt? It is p dx, that is fp plus q fq. Okay. So these are the first three characteristic equations, 1, 2, and 3. Where did we get this equation? This equation is the plane equation. dz is equal to p, this equation. dz is equal to p dx plus q dy. So from that we got the dz. Now we need two more equations. dp upon dt is equal to 0. What is dp upon dt and dq upon dt? So how to get this? Now go to the equation p and q is equal to 0 and differentiate with respect to x. What do we get? If we differentiate with respect to x, we get fx plus y is an independent variable. It is an independent variable, so 0, and z is so fz into ux, that is p plus fp into px plus fq into qx is equal to 0. So from here, what is next step? But qx, what is qx?
Sir, can you please repeat the above steps? I could not understand that. Where did we get dx upon fp is equal to dy upon fq from?
Okay. So yeah, come back to the plane equation.
Yes,
We have this equation. This equation is the equation of the plane, right?
right.
So so from here, if you what is so now differentiate this with rest, because this is a family of one parameter family equations, plane equations, right? Only
Yes,
parameter is p here. That
right.
parameter is p. Now what we did in this example also to get the envelope. Uh, so another thing you have to, before going to that, why we are doing all these things is, if you keep the picture in this picture in your mind. So x, y, z, and this is the solution surface z is equal to uxy that we are seeking for, and take any point, and at this point, what is the tangent plane at this point to the surface, and having a normal vector pq minus 1. We are going by these planes, right? So whenever we are asked to solve the problem, we will be given also how do we generate this thing. We will be given also an initial curve. So we will be given also the problem x y z ux, sorry, ux uy. This will be given also, and ux comma 0 or 0 comma y, some initial condition hx also will be given to us. Whenever the problem is given, we will be given these two also. So this is what this is the initial curve gamma, which we can parameterize it as s comma 0 comma h s, or in general f of s, g of s, and h of s. The whole idea of method of characteristics is that we are given a initial curve, and we are generating the characteristic curves at each point of this initial. So somewhere we have this initial curve like this, and we are drawing the characteristic curves like this. So along the initial curve, what we are doing is, for a fixed, we are generating these planes. We are going by the planes, tangent planes at each point of these initial curves, and normals, taking the normals as PQ. So we are looking for a family of tangent planes, and yeah, and also, yeah. Now come back to here. We want to look at the tangent plane equation. This is the tangent plane equation, and how do we get the curves? Envelope curves is by intersection of these two things. One is this one, and another is derivative of this with respect to p. When p is there, when you differentiate with respect to v, we get 1, and this dq upon dp. Okay, this one equation. Write this as dx plus dq upon dp into dy is equal to 0. Okay. And to get a second equation, what we are doing, we are differentiating this given f x y z p q of p equal to 0, this equation with respect to p. When we differentiate with this with respect to p, what we get? Fp plus fq into what is the dq upon dp is equal to 0. So these two equations, if you compare, if what are they? What should be the? This should be proportional to this, and this should be proportional to this. So in symbols, it is like, in parametric form, we can write it as dx by dt is equal to fp, and dy by dt is equal to fq. Okay. So this is what we have to do for obtaining the first two equations. And from the tangent plane equation itself, directly from the tangent plane equation, we get the third equation directly from the tangent plane equation, from this equation. This equation is dz, that is, to get dz upon dt, you have to write p times fp is this one, and fq is this one. Okay? That's how we got these three equations.
This is
Now we
for
are looking for.
curvilinear case. This is for
Pardon?
curvilinear.
Pardon me?
You said about equation of tangent plane, is it for quadrilinear case or general case?
No, no, no. This is general. Why I gave the quasi-linear case is just one simple thing that to write implicitly. Why we are taking the quasi-linear case here is to show that we can write Q in terms of P, but in general case we are using implicit function there. Quasi-linear case we are writing because here only left out things are P and Q. You can write Q in terms of P. Okay. This is finished. This has nothing to do here. So again, we come here to general case and yeah. Oh, you are asking quasi-linear case also. This will be coinciding. Yeah, if you take the quasi-linear case in particular, it will coincide.
So, sir, how we got the equation of tangent plane?
Equation of tangent where?
Uh, equation of tangent plane. Just a second. Dx, dz by dz equal p dx plus q dy. Here we get this.
Yeah. How do what is the equation of tangent plane actually? Equation of a tangent plane perpendicular passing through a perpendicular. This is sorry, having a perpendicular. This is the equation, na?
Yes, sir, I got it.
This is the equation. So whenever we are having this thing, okay, differentiate and you get. So now come back here. Yeah, three equations. Now, so instead of having a curve, we will have a initial strip. We are trying to generate initial instead of a curve, we want a strip now. Strip means it will
Sir,
have, yeah.
sir, also is it by assumption that we are taking that dz by dt will be equal to 0?
Uh, no, where is the assumption? dz by dt is equal
Sir,
to.
because in the equation, sir, just scroll above. Above.
Yeah.
So
Here.
here, yes,
Here
sir.
we are
So
differentiating. See, these are the parameter. How do we get the second equation for the here? We are one equation is the surface equation.
right,
Another equation is the differentiation of that with.
yes. I think
Okay, how do you get
lost
the
your voice.
one?
Yeah,
One
yeah,
is the one is the given family of surfaces.
okay,
Another is because there is only one parameter, we can take another equation as the derivative with respect to that that parameter equal to 0.
okay, I get it.
So here we take by with respect to p. Okay. Now now what are now we want a gamma which is not just a curve but it is a strip. Sorry, phi s and psi s. Okay, because we have only two equations fp, three equations dy upon dt is equal to fq and dz upon dt is equal to pfp plus qfq. Okay, we need two more equations dp upon dt and dq upon dt is it. So five equations. We need also five initial conditions. So initially it should be five fs, gs, and hs, and we need something for something for p also, something for psi also. So that's why we have to find out what are these phi s and psi s. Okay. To obtain this, what we did was we differentiated with respect to x. We differentiated the given equation with respect to x. So fx, fz, fz into p plus fp into px, and so what is qx. Qx is already q is uy. This is equal to uxy. Okay, and mixed derivatives are equal, so this is equal. And what is this is py. Okay, py. You can write replace qx by py. So now from this what we get? From this dp upon dt. Where is dp upon dt? So yeah, dp from here. This implies now this is dx upon dt. This is dy upon dt. So what we have is equation I'm writing here freshly, that fx plus fz into p plus um, dx upon dt px plus dy upon dt py is equal to 0. So this is dp. This put together is dp. So dp in parametric form, dp upon dt is equal to minus fx minus p times fz. Okay. Now similarly you can do obtain what is dq upon dt by differentiating with respect to y. This will be u z. Okay. So we have now 5 ODEs. And what are the 5 initial conditions? Now we have to obtain 2 conditions for phi s and psi s. First of all, the phi s psi s should satisfy the given. It should be in the equation. So this should be true. Hs, phi s, and psi s. This should be equal to 0. This is the first condition. And second condition is the the planes that we are having should fit in each other. Is they should suppose this is our initial curve gamma. Whatever planes we are finding, they should be like this. Scaled. Scale means like they should be fitting to each other. So these are the planes at each point with the perpendiculars. Okay. So to what is the condition that they should at the interface they should have coincide? That is the condition where we should. What is the condition is that dz is equal to, this is the plane equation, dx plus q dy. Okay, that means this dz upon dt is equal to this. What is at the initial phase itself, this should satisfy, means this is our h prime s equal to p. Initial p is phi s, and dx by dt is what? F prime s plus initial is psi s, and dy by dt is g prime s. This is the second condition. Second. So two unknowns, that is phi s and psi s, can be obtained by solving the two equations. First is this one, this equation, and this is the second equation. So with this equation, we can find psi s and phi s and psi s, and update now. Substitute in the gamma and solve the 5 ODEs with these 5 initial conditions. Okay. Let us now look at one example. Demonstrate this entire thing. Yeah. So take take this example. Ux uy is equal to u. So what is f? F x y z p q is identically is equal to write this as p q minus z is equal to 0. Okay. Now and the initial condition is given as with the initial condition u comma 0 comma y is equal to y square. So initial gamma is equal to what is fs 0, gs is s, and hs is s square. Okay. Now next is find the ODs. Or you can find first the another phi s and psi s. Find phi s and psi s. What is the first equation that phi s psi s should satisfy this equation? That is,
Sir,
yeah.
sir, how are we getting this 0, comma, like it should be 5, tau should be 5 parameters, right? We have to take
Ah,
initial,
yeah. This gamma should be 5 parameters. We are finding the
yeah,
given only the we are only given initial x part, that is fs.
okay,
Fs is given, and this is gs is given to us, and this we are calling it as hs, and rest we will add the phi and
okay, okay, sir.
minus hs is equal. This is, and second equation is h prime s. What is a h? Second equation is h prime is phi s. What was the, yeah, here is yeah, this equation f prime plus psi s times g prime. So h is given to be s square. H is given to be s square. So 2s is equal to phi s times f prime is 0 plus psi s times g prime is 1. So from here, what we get is psi s is equal to 2s, and put this psi s here. So phi s from 1 is equal to hs is s square. So this is equal to s by 2. Okay, this is s by 2. So these are the initial strip gamma is equal 2s. Okay, and this is the dx upon dt is equal to f, that is q, dy upon dt is equal to fq, that is p, dz upon dt is equal to p fp, and plus q fq. So this is 2 PQ, but PQ is equal to Z. So dz upon dt is equal to 2Z. Minus Fx minus Fz into P and minus Fz is minus 1 times P. So this is equal to P. Similarly, dq upon dt is equal to minus Fy minus Fz in Q. So this is 0 minus 1 into equal to Q. So now go ahead and solve these. We can solve these things with the initial conditions. So first, what we can solve is Z. Okay, dz is Z is equal to C1s into exponential 2t. Okay, you can write this implies that dz upon z is equal to 2 dt. Integrating both sides, we get ln mod z is equal to 2t plus constant. Now, now take the z is equal to exponential this thing, and that constant is here. And similarly, these equations dp upon these equations will give us pst is equal to, and even you can substitute t is equal to 0. Z0 is equal to C1s, that is equal to s square. ZST is equal to, what is C1 s square exponential. This is the final answer. Similarly, dt is b. So sorry, PST is equal to some C2S exponential t. So put this PS0 is equal to C2S, but PS is 5S. 5S is what? S by 2. So PST is equal to S2 exponential t. Okay. Similarly, QST will be 2S times exponential. And now come to the equation dx by dt. Is FP, what is that FP here? What is the first equation? Dx by dt is equal to Q. Q is this one. Now integrate. XST is equal to 2s exponential t plus constant C3 of s. Now put t is equal to 0. C3 is also 0 because fs is 0, because the x at the initial point is 0. So C3s is 0. So because C3s is 0, what we get is it correct? Or, three. Put t is equal to 0, then we'll have sorry. So this implies C3s is equal to minus 2s. So XST is 2s times exponential t minus 1. Okay. And finally, find the dy, solve the this thing is equal to p. P is what? S by 2 exponential t. Integrate, we get ys t is equal to s by 2 exponential t plus c4 of s. Now ys0 is equal to s by 2 plus c4s, but ys0 is s. So this implies c4s is equal to s by 2. So y is exponential t minus 1 plus 1. Okay. Now final step is write, get rid of these s and t. That is, observe that x by 2 plus 2y is equal to what? X by 2. If you bring this 2 here, s into exponential t minus 1. And what is 2y? 2y is plus is equal to 2s exponential t. 2s exponential t is what? Z. 2s exponential t is our, yeah. So and also use this, if you square it, it will be s square exponential. So what is z here? What is a z? S square exponential 2t. This is our, right, this 4 here. So finally, z is equal to uxy is equal to x by 2 plus 2y whole square. Or, yeah. So this is the procedure to solve the fully non-linear equation. So what are the other things here? We have
Sir, what did we write
and
dp
now
by
you can
dt
go
as?
on. dp by dt.
Yes, sir.
dp by dt is what is the equation? This is the equation, huh? How do we
Okay.
write? Huh? Yeah. So this finishes the lecture, this thing, and next is there is something like complete integral. This is what we have to do in the next topic. Next topic is complete integrals and general solutions. So in this, so complete integral is a two parameter. So shall we do this in the next class? We'll do the complete integrals in the next class. So we will do a little. We will also solve the exercise sheet 3. Okay, these two are left out now. let us do one by one, and let us not rush to complete everything. So this may be on Tuesday, and this on Wednesday, and only on if you like, if you want, we can have on Friday our exam. Friday is okay. And uh, like independent papers, the question papers will be different for each student. So if you are collaborating with another person, you have to declare in advance, and you will get only half the credit. If you are not collaborating, then you will get full marks. But you have to declare in advance the one person with whom you want to discuss the questions. So we'll yeah. Let us first complete on Tuesday this part, complete integral, and Wednesday we'll go through the exercise sheet, and then we'll have exam. Is that fine?
Yes, sir.
Yeah. Usually also minor one will be 1 month, like 3rd Feb our class started. So around 3rd March only we'll have the first minor exam. Okay, thank you.
So, sir, on Monday we don't have any quiz now.
No, Monday we are not having because we could not complete everything. I thought I could complete, but we no need to rush so much. So
Okay, sir.
we can leisurely have around 5th March, 5th March or 3rd March.
Sir, in tutor 2, question number 3, we have to take the g of u is equal to u square by 2 for calculating
Question
the
number 3 of just a minute. Okay. What is that you are asking?
Sir, how we get the g of u is equal to u square by 2?
U square, right? G of square by 2, correct. U square by 2, correct. G of is yes. Then
No, sir, how we will get that?
how we will get this? Okay. So G of u is what is the equation given? Burgers equation, na? Write the
Yes, sir.
given equation ux plus uy is equal to 0. So usually we compare y and t are same. So write this as g of u times x is equal to 0. So this is ut and this is, so g of u is u square by 2, x is equal to 0. Okay. So 2 ux upon 2. So this is ux. So ux is can be written as g of u. G of u is u square. So you are asking why it is left hand, the entire gu is u square by 2.
Yes, now it's clear, sir.
Because gu.
Uh,
No.
and in sir, question number 4, we will get a wedge since ul less than ur.
Yeah.
So in the final solution of ux comma y, we have 3 components like. So how we will get the second one when x is between x naught plus uly and x naught plus ury?
This is yeah. In the wedge-shaped region in between, what is the function? What is the function? It should be. How did we get? By problem 5. What problem 5 says? Problem 5 is the general GU, right? In In particular, our GU is in this problem u square by 2. So what is G prime u here? G prime u is just u. And inverse, what is our uxy according to problem 5? It should be v of x by y. This v is this v is G prime inverse of u. Okay. So here it will be, what is the G prime? It's an identity function. G prime inverse. G prime is identity function. Okay. G prime inverse of u will be what? It will be just x by y. So this v will be just x by y in our case. So that's why it is coming to be, because there is a translation of one x naught. That's why we in the solution we are writing it as x minus x naught by y.
Okay, sir.
This was when the jump is at origin. In our example, the jump is at x naught.
Okay, sir.
Shall we close it?